Hello, everyone. My name is Jerry, and I am a fourth-year computer engineering student from UBC in Canada. And today I will be presenting about my project for Open Mainframe Mentorship Program under the zopen community, where I worked on porting Bliss to ZOS. First of all, I will pass it to my mentor, Igor, for a quick introduction about the zopen community.
Hi everyone, I'm Igor Todorovski and I lead the zopen community. It's a global initiative hosted by the Open Mainframe project. For decades, the mainframe and open source worlds really felt like they were in two different continents. And our mission at the zopen community is to try to unify these two worlds and make ZOS a first-class open source citizen. And to achieve this, we built our initiative about 3 years ago on a foundation of transparency and collaboration. From day one, all of our code, releases, and discussions have been open to the public on GitHub. More importantly, we also follow the core principle of upstream first. We don't just leverage the open source code and port it to ZOS, but we actively contribute our improvements back to the original projects, strengthening the entire ZOS open source ecosystem. And the results really speak for themselves. Within 3 years, we've grown from a handful of utilities to a portfolio of over 250 open source tools running natively on ZOS, complete with a package manager that really makes it all seamless for the client. And the portfolio now spans from foundational tools like Bash and Git to modern applications for AI inferencing, specifically with Llama CPP. And the expansion to modern tools has naturally led us into AI. And I'm really thrilled about the work that Jerry has been leading here. So as technologies like agentic AI are becoming more and more prevalent in our day-to-day work lives, the conversation really becomes about data security. This is where the mainframe's unique advantage comes into play. It's also about providing critical efficiency so that you can run a lot of these powerful AI models locally on the system so that you can keep your data secure. So now I'm really excited about some of the work that Jerry has done around this space, and I'll pass it off to Jerry to explain a little bit more.
Thank you, Igor. Now let me introduce Plus and Bliss and how they differ from each other. So Plus, or basic linear algebra subprograms, is a standardized collection of routines for common linear algebra operations. This, for example, includes vector addition, dot products, and matrix multiplications. It is divided into 3 levels: level 1 for vector to vector operations, level 2 for matrix to vector operations, and level 3 for matrix to matrix. Plus has been around for decades, and it is the foundation for many scientific and numerical computing libraries. On the other hand, Bliss, short for Bliss-like library instantiation software, is a modern framework developed to implement the functionality of Bliss, but with more flexibility and modularity. Bliss is designed so that developer can easily adapt to a new architecture by plugging in optimized kernels. It simplifies extending and maintaining the library while still delivering performance comparable to or even better than legacy Bliss implementations. So the key difference is that Bliss defines the specification and a fixed interface, while Bliss provides a framework that makes it easier to tune, extend, and port linear algebra routines across platforms. As Igor mentioned before, the main motivation for porting Bliss to ZOS comes from the need to integrate with Llama CPP, which is an increasingly popular project for running inference on large language models efficiently. Llama CPP depends on fast and reliable Bliss routines, and Bliss offers a strong candidate because of its flexibility and performance. By porting Bliss, we can take advantage of optimized kernels that accelerate operations like matrix multiplication and tensor operations. On ZOS, this means we can better utilize the hardware, reduce computational latency, and also improve overall throughput for AI workloads. Beyond just performance, this work also has strategic value. It allows modern AI frameworks like Llama CPP to run efficiently on enterprise systems, bridging the gap between high-performance computing and mission-critical business environments. Porting Bliss to ZOS was a simple effort, and zopen meta tools, provides us with most of the tools we need for this process out of the box. So this process starts with setting up the environment, which involves getting access to a ZOS machine, as well as installing development tools, including Git, Make, Vim, which are all available through the open tools. And we also need to generate a port template, and this is readily available through the open generate for scaffolding the ports. We also need to build the port, and we can utilize the open build for compiling and testing the cycles. We can also configure the dependencies through a script that's available under the scaffolded project called build env. And moreover, we can also apply patches, which involves fixing issues that we encountered during builds. Some of these issues are ZOS specific because, for example, certain runtime libraries is not supported on ZOS, and some of the issues could also be generic, which means it's shared across platforms. After successfully building the tool, we also need to validate the tool. And we can simply do that by adding some script to the open check results to capture Bliss's test results to ensure performance of the kernels and the compile and the run. After validating, we also should be able to release the tool to the public. And the open meta tool allows us to create a repo under the open community GitHub, and also enabling CI/CD pipelines for ongoing builds and making it available for all ZOS customers. Finally, it also allows us to easily integrate with other tools that's on the open through adding dependencies in build env and also some compiler flags. I have run into a number of challenges during the process, and one of the examples was the missing runtime feature. For example, ZOS doesn't support things like thread or pthread barrier types in the C runtime, so I had to modify Bliss headers to work around those unsupported features. But the issue I spent the most time on was a test suite runtime crash that appeared when I upgraded Bliss to version 2.0. At first, I was completely lost. I was reading through a massive code base without really knowing where to focus. I tried the usual debugging approach, adding printfs everywhere, but that didn't help me narrow down the problem. The breakthrough came when my mentor introduced me to compiler tracing with Clang. Luckily, this feature is integrated into the open meta tools, so I could enable it with a single flag. This build produced a JSON trace file that captured function calls and memory allocations. With the trace data and some help from AI tools, I was able to quickly pinpoint the root cause of the crash. A variable was left uninitialized in one of the thread initialization procedures, and this led to an undefined behavior. Since this contribution is not specific to ZOS, I also created a patch for this issue and created a PR to upstream to the Bliss repo. This experience did not only solve the immediate problem, but also gave me a powerful new way to debug large-scale projects on ZOS. So now we will dive into a demo demonstrating what the user experience is like for Llama CPP before including Bliss and after using Bliss. So this is the experience without Bliss. We will be running a Gamma 3 1D model. So we will first load the model and ask it a very simple prompt like, hello, who are you? So a very simple prompt, and we should expect something very fast from it. As you can see, it will start generating all the tokens from one by one, and you can probably find out that it is very slow comparing to what you would usually see from LLMs. Now we will move to a version with Bliss enabled and see if we get any performance gains. You can see we will be running the same command, and it will also load the model, and this is with Bliss enabled. Uh, this time we will try something more complex. For example, write a story about the open community and open mainframe project. As you can see, it will start generating all the tokens, and you can probably see a pattern that it gradually speeds up as it generates more token. So that should give us a idea of what it's like using Bliss and without using Bliss. So these evaluation results are from the Gamma 3 1B models, and we will be comparing the performance between a plain CPU execution and plus optimized execution. So we tested both with different benchmarks. This includes PP64, PP512, TG16, and TG128, where PP stands for prompt processing and TG stands for text generation. The baseline of the evaluation is the current Llama CPP, which relies on plain CPU execution. For prompt processing, we saw a 86% increase in tokens per second on PP64, but 33% decrease in token per second on larger prompts. For token generation, we saw a comparable result for smaller number of generations, and a huge performance gain on larger benchmarks, which is TG128. The token generation speed was increased by more than 2 times. We noticed similar trend as we saw similar during the inference on Llama CLI. We also tested both single-threaded and two-thread setups using two benchmarks, PP64 and TG16. We noticed that as threads increase, the relative benefit of BLAS decreases because CPU parallelism already boosts throughput. To conclude everything, our evaluation shows that BLAS provides significant performance gains for certain workloads where throughput was doubled in tokens per second. Overall, the results demonstrate the clear value of optimized nice libraries on ZOS. I wanted to also take a moment to thank my mentor Igor for his guidance throughout this project. Their support was instrumental in helping me overcome challenges and learn new debugging techniques. These amazing results wouldn't be possible without his support. Looking ahead, I'm excited to continue contributing to open source community as a whole, helping to improve performance, broaden accessibility, and build tools that empowers developers everywhere.